Sometimes equations that look very similar lead to very different results. Let's use these three simple equations, all linear in just a single variable x, to illustrate that. We've gotten good at distributing across parentheses, and so we know that that's our first step. We're going to distribute across parentheses here, and that's going to give us 4x minus 12. We're going to do the same thing on this side. And that's going to give us negative 4x plus 12. So to proceed, we now want to collect all of the x terms together on the same side. There are two different ways we could do this, but my preference is to add 4x on both sides so that we can eliminate this negative 4x. That leaves us with 8x minus 12 equals 12. Now we're trying to get x by itself. To get rid of this, a negative 12, I'll add 12. That eliminates this, and I finally have 8x equals 12 plus 12. That's 24. I divide both sides by 8, and x equals 3. That's pretty typical of the problems that we've been doing up until now. Now let's take a look at this. Again, we start by distributing the 2 on both sides of this equation. I've got uh, 4x minus 12 equals 4x plus 12. The same situation here is that we'd like to bring all of the x's into the same onto the same side of the equation. So I'm going to subtract 4x here, and therefore I have to subtract 4x here to keep the equation balanced. Okay, now something interesting has just happened. The x's have been completely removed from the equation, and all that's left is negative 12 equals positive 12. But if you think about this, there's no possible way that negative 12 could equal positive 12. So what's happened? Well, it's not that we've made a mistake. It's that this is an equation that has no solution. Namely, no value of x will ever make negative 12 equal to positive 12. And so we say no solution. Finally, let's look at this case. Again, very similar in appearance. We'll begin by distributing. And what do we get? I've got 4x minus 12 equals, be careful here, 2 negatives. So that's positive 4x. And then negative 2 times 6 is minus 12. Okay, again I want to get all of the x's together, and so I'll subtract off 4x, but I have to also do that here. Once again, something unusual has happened. The x's have been removed from the equation. But unlike in the last situation, where we get something that seemed like nonsense, namely negative 12 equals 12, here we simply get the statement negative 12 equals negative 12. Well, this is certainly true, but is it useful to us? Well, in fact, what this is telling us, even though the x's have been eliminated, this is telling us that no matter what value of x we choose, we'll always get a correct answer. And so this case is what we call infinitely many solutions. So how can we distinguish these situations and make sure that we're doing the right thing? Well, regardless of what case you're looking at, you always want to first distribute and then collect all of the variable, when there's just a single variable, onto one side. Normally when you do that, you can then isolate that variable and it gives you the answer. The resulting equation gives you the answer. Sometimes when you attempt to collect all of the x terms on one side, the x terms leave the equation entirely. And in that situation, either you are left with an expression that is definitely not true, or you're left with an expression that is always true. If the expression is definitely not true, you conclude that there is no solution. There is no value of x that will make it true. On the other hand, if you end up with an expression that is clearly true, no matter what x is, then we have infinitely many solutions. Any value of x will work.